Hi, my name's Dave Lannom with Monroe Training, and welcome to today's segment on circuit faults. Today, we're going to be discussing part five, excessive resistance, and how we find that using voltage drop. Our agenda is really kind of simple. We're going to talk about why we're going to be using excessive resistance. Remember, common sense is always your best tool. We're going to apply Kirchhoff's law, where all the voltage in gets used. We're going to talk about diagnosing excessive resistance. We'll do a quick demonstration and then a summary. Now, keep in mind, there's other training that you're going to need to complete this one. The schematic symbols, basic electricity, relays, digital volt ohm meters, all the circuit laws, and the previous training that we've done on the other circuit faults. So, why do we discuss circuit faults? I mean, it's still the same. With the proliferation of electronics in today's vehicles, we should never send a gas to a competitor for repair. Excessive resistance is one of the most common but misunderstood faults. By understanding the basics, it makes any testing basic. And by understanding the testing of the four faults, we quickly, by understanding testing of the four faults, we can quickly and accurately provide confident diagnosis to the guest. And when we're making a confident diagnosis, that builds guest confidence, resulting in the referrals of friends, family, and coworkers. So let's talk about finding resistance using voltage drop. But first of all, let's go back and review the definition of voltage drop. And quite simply, voltage drop is simply the amount of voltage being used by a component, a conductor, a connector, or ground. Symptoms are simple. When one circuit's operating, less than source voltage is available, which is going to cause a dimmer light, a lower fan speed, or unexpected voltages that could actually fault PCMs or sensors. And we got to remember that when we leave wires undisturbed, they seldomly lose their insulation. Most voltage drop issues occur where there's no insulation, or like the ground's conductor asperity at the connections, or damaged insulation, or possibly a high heat circuit. So, what's voltage drop? It's simply the result of current flowing through a resistance. When we went back to basic electricity courses, it was E, the voltage, was equal to the current multiplied by resistance. So when current flows through the resistance, the result is a voltage being used. And remember, voltage drop is always going to be the most valid test for resistance because it measures the circuit under load. In other words, if we're going to test for voltage drop, the circuit has to be operating. In other words, turn the switch on. So, where is the voltage drop going to occur? Any place that we end up with corrosion, a connection between a body and a ground, where we've got frayed wiring or exposure to the elements, or even at the connectors. So, what's the extreme? I mean, the absolute extreme voltage drop could actually take you into a situation where, if the vehicle is fully recalled. The 19 and 20 Discovery was a classic example of it, with a loose contact between the battery ground stud and the chassis gave all sorts of electrical faults. In some cases, the vehicle just shut down or lose its exterior lighting with an increase of risk of a crash. As a result, Land Rover did a full recall of those vehicles simply to replace the ground and fix the excessive resistance. So I'm going to chase the voltage drop from the excessive resistance. What tool am I going to use? I'm going to be using my digital volt ohm meter, and I'm going to set it on volts. And remember, across a good operational conductor, the voltage drop should be nearly zero. Remember, the voltage should be available at the source, the battery, the alternator, or the load, the component that's being operated. So when we get a reading of 2 volts between battery negative and chassis ground, it tells me there's excessive resistance there. And the result is voltage is being used at the ground instead of inside the circuit. Now, we're going to have to go back to our schematics, and we're going to be looking at some component locations, harness routing. We're going to be looking at component locations, harness routing, connector identification, terminal identification, as well as we're going to be using the power and the ground distribution pieces of all data to diagnose some excessive resistance issues. So, what's it look like? So, remember, just like all electrical problems, you've got to think about not only how the electricity flows, but where the electricity flows. Remember, in order to test for voltage drop, I've got to have current flowing. The only way to test for voltage, for high resistance using voltage drop, the only way to test for high resistance using voltage drop is to have current flowing or the switch being on. And remember, the most likely location is the conductors that are not insulated, like exposed grounds, or components that carry large currents and are subject to heating. Connections are subject to developing high resistance as a result of conductor asperity. In other words, there's not full contact all the way through the connector. And as a result, the electrons literally have to jump, just like it would in a spark plug, causing heat at the connection itself. So when we do this, we're going to look at the components that share power and are ground feeds to help narrow the root cause. So let's take an example. Let's take the 2015 Chevy Silverado. Maybe a customer complained of the steering jerk or kicks back. Reduced power steering assist, engine stall, no start. The service, StabiliTrak, IPC, radio, HVAC, all goes blank. All sorts of diagnostic trouble codes, various functions and controls inoperative, lamps, displays dimming, and various service system messages displayed. So here's a classic example. So when we look at all those different pieces at one time, what we've got to take a look at is what do those components all have in common? So if we look at the ground side, the ground distribution, all of these appear to have their own separate and independent ground. Now, keep in mind that the battery ground cable to the chassis ground, that is common. So we're not going to rule out the ground in its entirety. But if we take a closer look at the power distribution, we start to see where all of these components are tied together where? At the power distribution module. So, at a particular point, since the affected systems all share power feeds through the battery fuse block, check the voltage drop here first. If no issues were found in the positive side, check the battery ground cables, as well as the electronics will inevitably terminate here. If no issues are found in the power side, check the brown cable. If no issues are found in the power side, check the battery ground cable, as all of the electronics will inevitably terminate here. So we're actually taking this information right out of a TSB. And what do you think the number one cause of all those problems was? You guessed it, caused by battery cables of high resistance or loose connection. And where they want us to check, either the positive or negative battery cable or the battery fuse block itself. So easy says easy, does easy. So let's see how easy it is to diagnose a high resistance problem using voltage drop by watching this quick demo. So in summary, remember, always keep it simple and always follow the schematic. Nope, that's not a mistake. I'm going to say it twice. Always follow the schematic. Remember, ground and power distribution will allow you to identify shared circuitry. And when in doubt, you can always pick up the phone. All data technical support. Hope this module has been useful for you. Thank you. And please have a great day.